Well, another in the series of vintage electronics repair, a Jaguar, or Jaguar as the professionals call it, Jaguar Model T2026 4-transistor tape recorder. I think it's cute that they call it high sensitivity super deluxe. What in the world does that even mean? But it does have the push button type, so we're going to take a look at this thing. I have not opened the tape recorder. I did take a quick look at the case itself, but I haven't opened the electronics. So it's in one of these Japan styrofoam cases, and look at this pretty tape recorder. I love the Jaguar emblem. And so let's take a look here. Brown case, no cracks, no deep scratches. Few little scratches there, but no, that's not a scratch. That's a casting mark. And look at the push button control. This looks a lot like a couple of the other tape recorders that I have. But let's see what is inside here. A hinged cover. Comes with the earbud. Don't see any human earwax on that, so that's a good sign. Another one of these beautiful little microphones. I just love these little Japan microphones. This doesn't look like it's ever been unwound. It probably has, but somebody knows how to wind them back. And look at this. The straps that fit on right here. Isn't that nice? Got its own little strap. Well, isn't that special? So, let's put her back in its original bag. And no telling what we're going to find here. This is the battery compartment. And, well, look at there. A D battery. And lots of foam rubber floating around in there, and a 9-volt battery. So 1D battery, 1.5 volt, and let's just test this battery with the super cheap battery tester. I'll get it the right polarity there, Kent. Says it's good. Says it's very good. So that's a good sign. I don't see any corrosion on the battery terminal. See there? Or on this side. Other than just a bunch of foam, I don't see any corrosion. Let's check this battery. Okay, it tests good as well. Now let's blow the soot out of the battery compartments. And not really sure what that foam was doing in there. Seeing as how the battery sets in this direction, not really sure what that foam was, but let's put it back together here. Loose battery terminal on the 9-volt positive side. There we go, nice and snug. Okay, slide it back in place, slides down neatly. And put the battery, the motor battery back in. All right, here's the acid test, folks. Forward, rewind, record, and play. Let's put it in play. Forward. Oh, cool. Look at that. And the motor is really trying. Okay. Let's rewind. Okay, feel a little bit stiff. If I let's take the tape off. I'm anxious to see what's on this, or hear what's on this tape. Okay, those rubber tires, look at how worn they look. They're just crystallized something fierce, which is not a good sign. So let's do rewind and see if this spins. Oh my. That's bad. That means there's a big heavy duty notch in the rewind roller. What about forward? Bad notches in the forward tire. Okay. So, why don't we just go ahead and take a look at those? Since we've kind of crossed the bridge here, we know what to expect. Let's take a look at the how bad these tires are. I want to get this close up to you. And they are very dry, by the way. But you can see how corroded. Oh my gracious. Look at the notches in that rubber tire. Two great big notches and another one here with a crack. So there's 3 notches in this tire. So this is the forward drive. Sometimes we can get by with switching the forward and the rewind, but this may be a different type. Well, this one still has a bad notch in it, but it has 2 notches in it. One here and one here. Let me see if I can get it close where you can see it. It's right here. Really deep notch. Let me put it up against the surface here and you can see the notch there. Big notch there. And then look at these. There's one there. And then there's another one right there. And then, you know, there's another small one right here you probably can't see against the white. But anyway, these tires are in bad shape. So one of the solutions that I had in mind for these tires was to grind off this lip. See this lip? Just grind off this lip completely. And then 3D print another flat tire that's about that thick, about 1 millimeter thick, and glue it on there and see if that would help. So we clearly have to do something with these tires, because they're just not, it's not so much important whether the rewind makes noise rewinding, but it sure would be nice to be quiet. One of the other repairs, if you remember, if you're those of you that watch all my videos, you may recall that I took some material, glue, and I filled these up with glue, and then I shaved them off. And that kind of sort of worked. It wasn't all that impressive, frankly, but it did work. And that is an option here. The problem is, this rubber is as hard as a rock. I mean, it is just brittle hard. See how I can scratch it? And it's just hard as a rock. So the solution is not to fill these gaps. And of course, remember that we also put a piece of heat shrink on the motor. I wonder how the motor sounds. Yeah, it's a little noisy. It's a little noisy, but I've heard worse. So for this repair, we're going to have to do something with the tires to restore the speed and agility of the Jaguar. So let's put some thought into this. If I could grind this or sand this down to where I could glue another lip on there, that might be the answer. So I need to ponder this. The other problem I have with 3D printing soft material is that it's a challenge to get a nice smooth surface. Although it just occurred to me that the surface that will be facing up will be the surface that prints on the print bed, and that will be glass smooth. So I could flip it over and have a glass smooth finish to work with. And if I used some kind of a rubber cement to glue them together. Another big issue we've got is that we need to make sure that it's flat, and it is not. It doesn't. I don't guess that it would change this wow and flutter too badly if it was a little thickness was a little different. A little inconsistency of the thickness of the tire, so that it's not riding up and down, because the motor is forgiving and the motor will ride up and down on that tire. But we sure can't deal with these notches. That's definitely not going to work. And this is so bad and this is so hard, it really surprises me that the tires turn at all, because this rubber is just completely crystallized. Another option, of course, is to break off all of this rubber completely from the spindle and 3D print a brand new tire. But frankly, I've considered that before, and it needs to be able to have the tire cross section looks like this. And I don't know that I can print a 3D printed tire with that configuration, because of the this is the tire. There's a notch here, of course, and then this is open, and then I've got this to print. So I don't know. I don't think that's going to work either. So I think what we'll do is we'll check to see if the amplifier is working by just getting this to turn. What I'll do is put a little bit of something in here to get it to where it'll actually spin and not just stop in that notch. And we'll listen and see if we've got an amplifier issue. Hear that? Knock it falling into that notch. So we'll put a little bit of glue in there and let that set, and then I'll come back and we'll let the tapes play and see what all the amplifier is doing. Okay, finished gluing and sanding the tires for a temporary fix. I used epoxy, 2-part epoxy, and filled in the grooves. They're not perfect, but they are a little smoother. And as you can see, a little better. A little bit of a lump right there. Glue is starting to let go. It doesn't hold on to this rubber very well, but I really just wanted to test the transport system. And so I put grease on it and a little bit of oil, and the rewind is a little noisy. Oh, and I also put, as you can see here, heat shrink tubing on the motor, on both ends of the motor. A little bit of heat shrink there. Of course, that changes the pitch. of the speed of the reels, but right now we're just trying to get it to run. You can hear it. It's still pretty noisy. And we definitely have some corrosion on the switches we need to take care of. I just love this little setup here. Forward and rewind. That's so cool. So what we'll do is we'll pull these screws, pull the whole set out of the top, and we'll spray these switches and the volume control and the record and play button. We'll see if we can get some audio. Yeah, just a little stiff. There we go. Easy does it. Says motor is no good. I don't know what that means. Motor NG. It's our little amplifier, 4 transistor amplifier. These switches need a little bit of cleaner. Okay, that's a little quieter. And let's spray volume control if we can get it. And the record and play switch. All of us, oh, we got it in record, that's why. There we go. Okay, we'll turn the volume up. Okay. And we probably have an open cap on the, oh my, there's all that foam that we had in the, that we blew out. There's probably some on this side, yeah. So, get rid of that so it doesn't make it worse. And then we'll have to dump everything out. Okay, a little better. Let's turn it back around. Set it back in. Okay, I don't know, that looks like that spray might have gotten on the tire, so we'll see if it runs. All right, let's see if we have any audio. doesn't sound like it, at least not on that tape. And this tape is one that we used for another tape recorder, just to the Lloyds, if you recall. Okay, I can hear. Very faint. So we've got some work to do on the amplifier. Okay, we're going to test this board. I'm not going to just randomly replace all the caps, just simply because I want to do a test here to show a little troubleshooting technique. I'm going to turn on play. Now that's rewind. Okay, there's play, and I've got the volume turned all the way up. And here's where the audio goes into the device. We've got a 1K resistor here, and that's where the audio goes in. And then there's a cap, a 5 microfarad cap, that should bridge the audio into the amp. And so you can hear we don't have any audio hum here, but we have audio there. So got ever so faint, but plenty of audio there. And so that's telling me that that cap is probably open or nearly open. So let's stop the tape. Let's grab a 4.7 microfarad cap. I'll zoom out here. And we'll pick a cap from the collection. I'm out of 4.7, so let me just use a 10 for the test purposes. And we will take our screwdriver, put it on play, and we'll check our audio this way. Okay. And let's just bridge this cap like that. So what I'll do is I'll just tack this cap in here. I can hear I've already got audio. Yeah, you can hear it. So let's tack that cap in there and see if we can get any audio on the tape by just bridging that capacitor. I'm going to okay. Be just about as easy to replace the cap than to bother doing this, but I want to illustrate troubleshooting technique. Okay. Now let's flip this back over, put a tape in it. See if we have any audio. There may be other bad caps, but let's just see. Okay, forward. Okay, we're not in the track here. There we go. Forward. Okay, good sign. Okay, so we got one bad cap. We found that pretty quick. That might be the original tape that was on this tape recorder. Let's see if this is the one that we were using earlier. Let's see, forward. Yeah, this is one that you may recall on a previous recording that were a bunch of kids just chatting and playing on the tape player. Got a good amplifier, that's for sure. Okay, let's just plug the microphone in. We're just going to plug the mic in and click record and forward. All right, we are recording on the, what are we recording on? The Jaguar model T2026. And we're going to check and see if we have a recording functionality now that we've got some of the things cleaned up. And the volume is all the way up to max now. And we still need to improve the tire. But I think this may actually be a simple repair. Let's rewind it and test it. Okay, now watch. If I hit rewind now, it won't go. And it's because there's a safety function built in. Won't let you fast erase the tape. All right. All right. So the microphone or the record circuit is not working very good. We should have my speech there. So that was the microphone that came with this. Now we know that the diamond lapel mic is a really good and really hot microphone. So let's just record with that one. All right, we're now testing the recording functionality of the Jaguar T2026 with the diamond studded lapel microphone, which is very hot typically. I've got the volume turned all the way up to max, and the magnet is contacting the tape, so it's erasing it as right before it plays. So let's see if we get any kind of recording now. All right, so the recording circuit okay, so the record circuit is weak. I think what we'll do is go ahead and replace the other capacitors. There is a capacitor in the record circuit, and we can verify that with a 4 transistor schematic. But I'm going to go ahead and replace the caps. There are only about 4 on that circuit board that I can see, and then we'll test it again and see. There could be a biasing resistor that's open, or the value has changed. So let's take it one step at a time. Okay, I replaced one more cap in the recording circuit. And I finished soldering that other cap that we just had tested. I found another 4.7 microfarad, so I replaced those 2 caps. And so let's record. Alrighty, we're testing 1, 2, 3. We're testing on the diamond-studded lavalier microphone, and we're going to check and see if we're actually getting a recording. I'm going to turn the volume all the way up, and we'll see if we get a decent recording using the diamond-studded lavalier microphone, in hopes that we have solved the audio problem. See if we get a decent recording using the diamond-studded lavalier microphone, in hopes that we have solved the audio problem. All right. Success. Very easy peasy. So the audio is working now, and we didn't have to replace all the caps. So let me show you what I did. There's a cap right here on the record circuit. This is the record line that comes in, and there's the bias resistor. I checked that bias resistor, and it was okay. And so I checked this cap, or just replaced this cap in that circuit, and apparently it was bad, because that's all we needed to do. So we replaced this cap here, the input cap, and we replaced this cap here. There's another one in the circuit here, 2 more actually, but I'm not going to mess with them. It's working fine. We're going to leave it at that. This is not a high precision device by any means. So the only thing that remains now is what do we do with this spindle? Do we continue to fiddle with it with a 3D printed tire? Or we'll test it for music now. Okay, well, not terribly impressive. Remember, the cutoff on this microphone is pretty sharp. We could try another mic, see if we get any better audio quality. So while I'm recording here, let me just pop in another microphone. And we can try this one now that we know that our recording is working. And we'll continue the music. So crystal microphone is not all that great. Let's try the one that we know works. Looks like there might be a loose connection on that. Rewind. Alright, well, not horribly impressive. And we could rewind it, erase the tape, and try it again. But I think we've about got this one wrapped up. Alright, as you can see, I have sanded down the ridge off of the play tire down to a smooth surface, and then I 3D printed a ridge, or a belt I guess you'd say, and I'm going to glue this to the surface, and then we'll see how it works. I'll see the bright shiny surface. It should be nice and flat. The drive motor right here actually doesn't ride on the tire this way. Let me drop this down. It doesn't ride on the tire like this. It rides on the tire like this. And now that's an exaggerated angle. So as you can see, I ran the tire after I shaved it down, and you can see the little mark that the drive motor left on the wheel. So this may be thick enough to catch the edge of that drive motor. We'll see. And it may be thick enough that it'll ride a little flatter. We'll just have to see how it does. But I'm going to try to get this on perfectly round. If it varies this direction back and forth a little bit, then the motor is going to it's going to make it have some wow and flutter. So I need to get it glued on there pretty good, and then circle it like this till it's just perfectly. And of course I realize perfectly is just not even possible. And there are some little tags like right there. I pardon my dirty hands. They when I sanded this down, the material is just like black soot, and it makes a big mess on your hands. So if you'll just pardon my working man's hands there. So yeah, there's the bed side of the 3D printed belt, and you can see how smooth it is. Here's the top side of it, and it's not real bad, but it is a little rougher. So anyway, let's just try to get this thing glued on here. And I think I'm going to use contact cement. That's a little bit thick. I don't know. I really would like to have something a little thinner, but I guess I'll try the contact cement because it's instant. CA would work, but I don't have any CA that's thin enough. And I don't want to get the CA up on the edges of the belt, and it'll the capillary action will move the CA up onto the edges of the belt and ruin the softness of the belt. So let me get some glue on here and we'll see if we can get it to stick. Alright, I'm going to use some clear Gorilla Glue, brand new tube, in hopes that will be supple and soft enough thin enough to not create ridges in the motor. I'm sorry, ridges in the belt. Gotta work fast because this stuff sets up pretty quick. Come on. Yeah, see, it's already, as soon as it hits the air, it starts setting up. All right. Put the shiny side up. All right, I'm going to roll this on a flat surface. All right, I'm going to push this down onto the carpet because the spindle is a little bit longer, higher than the edge of the tire. And if I put it on a hard surface, this just rocks. So I'm going to set it down on this carpet and just push it down in. Make sure it's got a good seal all the way around. Looks a little uneven. In the light, you see that? Looks a little uneven, but that's definitely an improvement. Yeah, it looks a little uneven, but I don't know what to do about it. The rubber probably should have used a thinner glue. I don't know. We're just going to let the glue set. And dry. It's already dry, but I'm going to let it set for about 30 minutes before we put it on the tape player, and we'll just let it dry. Alrighty, having trouble with this camera. I probably shouldn't have used this camera. And I noticed that the camera is shifting back and forth. You see it moving? Oh, me. Okay. Well, it's completely quiet now. Before we had a clunking sound. So now it's completely silent, which is a good sign. But I'm concerned that the unevenness of the glue might be a problem for us, but let's just see what recording and playback sounds like. All right, now that's a recording with a dry tire. So let's try it now. And by the way, I'm using a little better microphone. This is a Webster Chicago, excuse me, Webster Chicago microphone. And it's, this connector is just a little bit loose here. On this jack, it's a little bit short. The other older microphones are longer, have a longer shaft. So anyway, I've got my cell phone over here, and I'm going to record. I want to get it away from the clunking of the motor, but there's no more clunking anymore, so that's good. Put the cord up here where the microphone will stay. Okay. And let's play some music. I don't know what we're going to have. Don't know what kind of flags we're going to have. It is significantly more quiet. That's a good sign. Okay, let's turn that off. Today, there we go. And let's rewind. This could definitely use a rubber tire, couldn't it? The grinding. Okay, we fixed one problem. We fixed one problem and created another. All right, now I'm going to record just with my voice and see what kind of quality we have with this Webster Chicago. I can never remember the name of that microphone now. I just have to turn it upside down. Webster Chicago microphone. I've got the volume turned down pretty low. Let me crank the volume up just a little bit. Anyway, we'll see what kind of dynamic range this mic gives us on our recording with speech. Okay, now we'll rewind. Hope you're not getting too seasick with this camera moving like this. I might try to take some of that out in post-production. Oops. But I'm going to crank the volume way up, all the way up. And let's see what kind of audio quality we get with talking in a normal tone of voice into the Webster Chicago. Oh, I got it right that time. Webster Chicago microphone, recording on the Jaguar model T2026, and we put a new tire, 3D printed tire, on the take-up reel, and we're getting a lot of wow and flutter on the recording, but the transport mechanism is so much more quiet now. It was clunking pretty loudly. So we traded one problem for another.
Chicago microphone, recording on the Jaguar model T2026, and we put a new tire, 3D printed tire, on the take-up reel, and we're getting a lot of wow and flutter on the recording, but the transport mechanism is so much more quiet now. It was clunking pretty loudly, so we traded one problem for another.
Okay. Well, let's do the same thing with this tire, the clunking tire. We'll get it quiet on rewind. The quality and the wow and flutter is of no value, of no consequence on the take-up reel. So, I mean on the supply reel. It's free spinning when it's in play. So the only time that we're going to need to be concerned about the condition of that tire is on rewind, and it's not a problem because it'll just quiet the whole tape deck down. That's the benefit. Once again, I'm going to sand this ridge down to flat so that it'll be down even with this surface, and then we'll glue a tire or belt, whatever you want to call it, onto this surface. And if we do any better with the gluing, we might be able to swap these reels if we can get this a little more even once I glue it on there. So I'm going to try some different glue. I might even try some I might have some CA downstairs that's super thin, because I think the CA would do a better job, and it wouldn't create this thick and thin glue spots. Okay, I have sanded the ridge off of this tire, spindle, and I've started 3D printing another belt, so we'll glue that on there and see where we go. Okay, I just sanded and cleaned that tire, and I did not put a tire on it yet. I'm going to just check and see what it sounds like on rewind. A little better, still a little noisy, not nearly as clunky, but you can hear how quiet play is with that rubber tire. So okay, so we've got something to compare it to. We'll put a rubber tire on it once it gets printed, and we'll go from there. Okay, I 3D printed another tire here, and it's using glue stick to hold it on to the thing. So what I do is I take a little bit of warm water and just run it around to help release the glue stick. It helps, it does a lot better job. I used to try to just dig it off, and that didn't work very well. It would stretch the belt real badly and tear it. So the water really helps, and it just basically comes right off once the moisture hits that glue stick. So here we go. Now I'll clean up all those threads, and nail clippers work real well for this, for the cleanup, but a really good pair of wire cutters, precision wire cutters, helps too. Depends on what you've got. And we'll get that glue off of there, because that'll just create problems for the super glue to stick. So let's clean this up, and then we'll glue it to the rim, the spindle. Okay, I'm back over, and as you can see, I bought some super glue. So we'll glue this to the rim, shiny side up, and we've got to clean up the stragglers here. Easy enough. So I'll clean this all up and then wash it one more time, and then we'll super glue it. Okay. Shiny side up. Then we'll press it into the carpet. Got this out of a line here, so that might be a problem. Yeah. You can see it's sticking out of over the edge just a little bit there. And that's going to be a problem. Maybe. I think it'll run quieter. And it's already dry. I think it'll run quieter for sure. But let's see how it sounds. Okay, put the E-ring back on. Give it a tiny drop of oil. Yeah, a lot quieter. A lot quieter. And we can probably remove the heat shrink. So let's do that. See what difference that makes if we remove the heat shrink from this side. Okay. Pretty quiet. Got a little bit of a noise. Play is beautiful. I'm curious, and you hear it going on. I'm curious if we switched them, let's just switch them. I'm curious if one is better than the other for playback. I wouldn't bother putting the E-clips back on each time, but the motors push the spindle up. So you need to have them on there in order to keep it. Okay. Still pretty quiet. Not a whole lot of difference in the rewind. But let's see what the quality of the wow and flutter, if the wow and flutter has improved. Not too great. It's quieter though on rewind. We definitely made an improvement there. Okay, there is one thing I need to do, and that is remove the now that we have rubber contacting the motor, let's take the stuff off here too, and that's going to change the pitch, the speed of the motor. But that's okay. We can re-record whatever for testing purposes. We just want to see if it's really quiet. All right, it's much slower. Don't freak out. Don't freak out. Definitely got a lot of wow and flutter, or more wow than flutter. So let's put the original one back on there. Okay. Nice and quiet. I need to clean those spindles up, don't I? Kind of nasty. Okay. Fairly quiet. All right, we're going to rewind it all the way and re-record a new music. Well, I'd say that we've made remarkable progress on the Jaguar T2026 tape recorder. I'm going to wrap this up, put it on the spindle, do a pretty exit clip, but I am very proud of the way that this all turned out. The retiring the spindles was an interesting project, an interesting attempt. Obviously, we didn't get it perfect, and I could have taken a little more care to make sure that the tire fit perfectly onto the spindle. I think we did better on the first one than we did on the second one. The second one definitely is a little out. See if this spins. Oh my. That's bad. Around. But listen to the difference in the sound. I might try to clip some of the earlier rewind and play videos side to side so that you can hear the difference. Because this has been a long video, but I wanted you to see the improvement that we made on the Jaguar. So very proud of the work that we've done on this, and thank you for sticking with me all the way to the end here. It's been a lot of fun working with you on this tape recorder.